A lot of stuff you learn in math is, the ideas were sort of come up with thousands of years ago, or once you go up to more and more advanced math, like near calculus and stuff. Even if you were to go to university and study things like multivariable calculus and things like that, you would be up to the early 19th century, most likely. Most of the stuff you learn, even as an engineer, is you're up to the early 19th century. Okay. The notation we use is maybe more 20th century for some of the stuff, but the ideas are just more than 150 years old. Most of all the math you learn. So strangely, most of the math you learn is kind of in a way very old. But tricoloring was invented by someone that didn't die too long ago, a man named Ralph Fox, who invented in the 60s, invented this in the 1960s, while he was giving, by then he was a pretty famous mathematician, he was giving talks to high schoolers, and he was like, knot theory is too complicated to explain to them because it uses all these things they don't learn about, as undergrads even. So he was like, how do I explain it? He came up with this. So somehow this is probably the most recent math idea in terms of the history of ideas that you have learned thus far. So that was kind of interesting. Okay, so so coloring. So here's the idea of coloring. Let's color. I put it in quotes because maybe it's not clear what it means, but really it just means label. Label each strand with one of three labels, and I'm just going to call them colors. With one of three colors and I'll call them 0, 1, or 2. And then when we actually have colors we can use 3 actual colors. So once it's not just a labeling, that's just a coloring, it turns out. So this coloring is a tricoloring. That's a new term here. It's a tricoloring if the following hold. Because right now you can look at the picture of, say, the trefoil that I drew, and you can see the strands, and you might be like, oh, I'm just going to label them, or in a moment I'll use chalk, colored chalk, and color each strand with the chalk. But that's just a coloring. You might be like, what's the point of that? There really is no point. But if you consider these special conditions that makes it a tricoloring, it turns out there's a point. It turns out not all diagrams will be tricolorable. So the two conditions are, I guess we can number them. At least 2 colors are used. Okay, and the other one, which works sort of in conjunction with it, is that at each crossing, either only one color appears, or all 3 appear. So what I'm writing down here is, or all 3 appear, all 3 colors. Okay, so let me draw a little kind of picture to indicate what I mean. So at a crossing, right, you have this kind of picture where 2 pieces of the knot cross like this, right? And you'll clearly see here's something that's part of a strand, here's something that's part of a strand, here's something that's part of a strand. So you can have up to 3 colors, right? So say the label here, whatever it is, I guess, whatever I pick, 0, 1, or 2, I guess I'll call it X. So X stands for 0, 1, or 2. And Y stands for 0, 1, or 2. And Z stands for 0, 1, or 2. This is Z. So I guess the thing is, either they're all the same, either X equals Y equals Z, or all X, Y, Z different. Okay.
Wait, wouldn't Z and Y be part of the same string? Or wouldn't that like string where Z and Y are, wouldn't they be the same color?
This and this?
Yeah.
No. They'll probably be part of different strands because remember, here's a break, right? So when you have a strand, remember, it goes up to something like that, and then here a new strand might start. Right? The only way it could be part of the same strand is if it went like this and it went around like this, right? Then this would be one strand, but that's going to be, like, you'll realize that doesn't make sense for a knot because if it does this, I guess it could go over stuff. But look at this. Here's sort of one thing, and if you think about what it represents, here's sort of one knot already, and what's this other chunk? Right? There's already one loop. A knot's just one loop in 3 space, so this kind of indicates some weird picture. So since we're talking about knots, this thing can't be part of one strand. It's going to actually be part of 2 different strands. Like this is going to go on and do something until it gets to another thing, and then this is going to be one strand, and this will be another strand. So they could be different colors. There's no reason they can't be the same color, of course, but Luke?
Is the reason you're using X, Y, and Z because you don't have, because isn't it normally colors?
Well, there's 3 colors. There's 3 colors.
And you have
and there's like many situations, well not many, but I could say like I want either there to be 0, 1, or 2, or 1, 2, or 0, or 2, 1, and 0, or 2, 0, I mean, I don't want to go through all that, so I call them letters, and I'm saying all of them are different. X, Y, and Z stand for 0, 1, or 2, and I don't have to say which, right? So that's very simple, so I hope that didn't sound patronizing, but I just want to be absolutely clear. It's clear? But of course, they could all be the same. I don't know. That's part of, it depends what I'm trying to do. Like for some colorings, you may want to make certain crossings the same. Luke?
All right, so when you were showing Jesse how that, if it's not would just connect like that, it wouldn't really be a knot. But in the end, doesn't everything end up connecting back together?
Yeah, but they're not, you're not going to have, I guess my point was, you're not going to have this strand actually be the same as this strand.
Right, okay.
But in terms of following the loop around to represent the 3-dimensional thing in 3-dimensional space, it is all sort of, it is one sort of journey around.
All right.
Okay. So any other questions? And then I'm gonna give some examples of what it means to tricolor things so you can see right now. So let's start with maybe one of the easiest examples. Examples of tricolor. And this kind of gets back to, sorry, I never remember your name. Catherine?
Yeah.
So it's kind of related to your question. So let's look at this picture here. So it's a standard sort of, a simple picture of the trefoil. All right, so how can we try to color this? I guess we could use colors here. I guess we can start out with any color. We could go like this. So here's a strand. Let's color it blue. Okay. Someone might say, let's just color the whole thing blue. Right, there's 2 strands left. Let's color the other 2 blue. Who wants to do that? Nobody wants to do that. Why not? It's an easy question. Why not? No. These are examples of tricoloring.
It's not tricoloring.
At least 2 colors are used. So I gotta use another color. Alright, so let's use, I guess I'll choose whatever. Let's do this one.
It is also boring though.
right? But okay, you might say at least two colors are used, and at least two doesn't mean